Unit 2, Lesson 5. In this lesson, we will be in writing, creating quadratic equations from real-world situations, and you're going to justify your answer. Notice here we have a whole thing telling you how to justify your answer. This is also located in your Desmos today. This is the first time I've asked you to justify your answer, and it's important that we do it correctly. So, let's move over here to a problem. Amari and Maria are launching rocks off the side of a 20-meter cliff. Amari's rock flies 5 meters higher than the cliff after 3 seconds and then falls to the bottom of the cliff after 8 seconds. Create a function to model the situation, draw a graph, make a table of at least 5 points, and label all key features and justify your solution. All right, it's a lot. So let's think of what we have. So we have a rock off a 20-meter cliff. So the cliff is up 20 meters. So his rock flies 5 meters higher than the cliff. So we can say that's probably about 25, right? Because if the cliff's 20 and 5 meters higher, that's 25. After 3 seconds. Okay, so after 3 seconds. And then it falls to the bottom of the cliff after 8 seconds. So the bottom of the cliff is probably 0, right? All right, so I'm going to put some lines down here. So let's look here and hopefully be straight as possible. Call this our y-axis here. Okay, and then we have our x-axis here. All right, so the meter is 20, the cliff is 20 meters high. Let's count by twos, right? So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, but we're not going to stop at 20 because we're going to have to go all the way to 25, right? So 22, 24, and then we'll call this one 26. Okay, so this is our height. Okay, so this is height. And this is going to be time in seconds. In our seconds. Oh god, I'm sloppy. Our x-axis is always some form of time. It's always some form of time. Okay, this is always time. And then y is whatever else we're talking about. All right, so let's start plotting some points. All right, so we know that the cliff is 20 meters high. So this we can say this is where the starting point of throwing rocks was, right? We can say it's on the y-axis. So we can call this our first point, and this one is 0, 20. Okay? Now, after 3 seconds, right? So 1, 2, we're going to go by single ones down here, and it doesn't matter that I changed it from the y to the x as long as I'm consistent within the same axis, okay? So after 3 seconds, the rock flew to 25, right here. So this will be the point 3, 25. Why? Because right now he threw the rock, it went about 5 meters higher. All right, so then after 8 seconds, it hit the ground. So it's going to go up, and it's going to fall down 8. So let's keep counting here. 4, 5, 6, 7. Call this one 8. So right here, here's 8. All right, so we're going to call this one 8, 0. All right, so this is where you have a situation. Amari's on his rock. He's standing up here on this cliff, right here. This is Amari. And his rock comes up like this and it hits its highest point after 3 seconds and then falls down. All right. So now we've drawn a graph. So we can check. All right. Now next, we're going to create a function to model the situation. So let's look at some points we already have that we know are going to make this easier. So right here we have a vertex, right? Because this is some form of quadratic. I do know that it's not going to go into the negatives here and it's not going to go below the ground, right? So this is a limited quadratic graph, and we'll talk about limitations when we talk about domain and range here in a minute, but let's start with just the equation. So I have a vertex and I have some other points. So I think the best one for me to use would be the vertex form, right? So that is f of x equals a times x minus h squared plus k, where my vertex is h comma k. So let's go ahead and put this in there, right? So we got f of x equals a minus, parentheses x minus 3 plus 25. All right, so I still don't have enough information to make an equation yet because I have this thing called a, right? And equations have f of x, right, y, and x, but they don't have an a. There's no special way to plug in a. So what I can do then is I can use any other point I want to solve for a. So I'm going to use this one right here, okay? And this is my x and this is my y. So my y is 0 equals a, what I still need, 8 minus 3 squared plus 25. All right, so I'm ready to solve for a, but I'm going to take it over here to another slide just because this is getting a little crowded. So let's come over here, and I got 0 equals a, parentheses 8 minus 3 squared plus 25. All right, perfect. Now I can solve this because I only have one variable. So let's start with inside the parentheses, right? So 8 minus 3, so this is going to be 5 squared. Let me keep this in the parentheses for just a minute. A plus 25. And no, it doesn't matter that I put it in this in here now. I can't do it until I finish the parentheses, but I'm going to do it now. And I kept the parentheses because I still want to multiply it by a. So 5 squared is 25, okay, plus 25. All right, I didn't write my a for a reason. Because a lot of you are going to put your a right here, and you're going to be like, Miss, I don't know what A25 is. But the reality is, it's the same thing if I write it over here too. It makes no difference. Okay? So I'm going to switch it here because this is more user friendly. Now I'm going to just go ahead and subtract my 25. Subtract 25 from over here. So I got negative 25 equals 25a. I'm going to divide by 25 on both sides, and negative 25 divided by 25 is actually just negative 1, and there is my a. Okay, so now I have a, and therefore I have a full equation. I'm going to take this and I'm going to put it back in here, but I'm going to keep my x and y this time. I'm not going to have this or this anymore. I was simply using that to solve for a. So my equation now is f of x equals negative 1 x minus 3 squared plus 25. Bam, I have an equation. So go ahead and check that, draw a function, create a function. That's what I did. Perfect. All right, so now we're going to make a table of at least 5 points. Well, guess what? I have 1 point, 2 points, 3 points already. Okay, I have 3 points already. So let's go over here back to my equation page, and I'm going to say x and y, right, because that's my table. Or you can write x and f of x and f of x, the same thing. Let's go ahead and put all the points I already have, which is 3, 25, 0, 20, right? Where he started at the cliff, his highest point. And then this will be our last one, which is 8, 0. But I still need 2 more points, okay? 2 more points. So I like to use, you can use whatever value you want for x, but I want to make it really easy, okay? So I'm going to go after 1 second and then after 2 seconds, okay? But I need another page because once again, I'm crowded, so let's go over here. So my equation is f of x equals negative 1 x minus 3 squared plus 25. So first thing I'm going to do is I chose 1, right? So I'm going to substitute 1 in for my x. So now I have negative 1, 1 minus 3 squared plus 25. Inside the parentheses first, so 1 minus 3 is negative 2 squared minus 1 plus 25. And you see me interchanging this 2 inside or outside the parentheses. It doesn't matter as long as the parentheses have already been solved. All right, so negative 2 squared is negative 2 times negative 2, which is 4. 4 times negative 1 is negative 4 plus 25. So now I have negative 4 plus 25, which is 21. So let's go ahead and put 21 on my table. Okay, so that's my next one, and 1 more point. I'm going to, but I want to make it really easy, so I'm going to use the same page. So let me get this all erased really quick. All right, so now I'm going to input 2 for my x. inputting 2 for my x. So I'm going to have negative 1, 2 minus 3 squared plus 25. All right, so 2 minus 3 is negative 1 squared times negative 1 plus 25. So negative 1 squared is positive 1. Positive 1 times negative 1 is negative 1 plus 25. Means I have 24. So if I input 2, I get 24. So here we go, 24. All right, now I got 5 points. I have a table with 5 points. Bam. Okay. Label all the key features and justify your solution. All right. So right now I have the y-intercept right here, right? Y-intercept. I have the vertex, which can also be the axis of symmetry. I don't have to do any math. It's already done for me. So the AOS is x equals 3, right? It's the x coordinate of my vertex. And then I have this point right here, which is the x-intercept. So I know in my head that quadratics have 2 x-intercepts. Most time this one would right here. But would the negative one matter here? The answer is no. And the reason the negative one doesn't matter because the rock can't go back in time. I can't have negative time. So therefore it doesn't matter. So the only thing left I have here to do, I got my vertex, I got my axis of symmetry, my y-intercept, my x-intercept, but I still need, we can also say vertex is also a max in here. We can also call that max. But I still need my domain. All right. And I know you previously heard me say that every domain of every quadratic is negative infinity or positive infinity, except for now. And the reason it isn't because this is a real world situation and it's being modeled. Okay, so the reality is the domain is going to start here at 0, which is included because 0 is a time, and it's going to go all the way here to 8, and it's going to stop. Why there? Because those are 2 points. Okay, so my domain is 0 included x less than 8 included. Okay, and then my range, right? Once again, I'm not going below the sea. I'm not going underground. So I won't go down anymore. I'll start at 0 and I'm going to go all the way up and don't stop at this point because that's not its max. I'm going to go all the way up here to 25 because this right here is at 25. That was really straight. So I can say it's from 0 included, y, to 25 included, right? Because it actually hits the height of 25. And there we go. This is how you solve it. Now, how can I justify my answer? Let's go back and read our justification. So label our work, check, right? So we check that off. Show all of your work, check. Explain how you got your answer. All right, let's go explain how I got my answer. All right, so let's get us a blank sheet here. And I'm gonna go ahead and use a text box. So explaining how I got an answer. So that's using sequential language. So I'm gonna start with first, I drew a graph of the situation modeled, or not spelled some days, modeled in, I'll write the first time, modeled in the problem. Okay. Next, I label my work to identify the key features then it doesn't matter what your words are. Then I'm gonna make this box a little bigger so I can go for this one. All right, ready? Then I used the vertex and another point to solve the equation and find the equation for A and I'm gonna say create because that's what the thing says. Created an equation. After that, I made a table of points using the equation the given points and two more inputs. And then lastly, I labeled the key features and wrote the domain and range. Perfect. What else do we have to do on here? What else is it asking us to just variant problem? All right, so we did this, right? So let's go ahead and check that one off. Explain why you chose an operation. I think we did this in our explanation. Explain how you know your answer is correct. Okay, that's something we can look at. Explain how I know my answer is correct. Well, in this case, let's go back in our. I know my answer is correct because and you can choose what you want to do here. Um, I'm going to say I do the graph, but you could say I graphed it on a graphing calculator or something like that. So I'm going to write I graphed the situation and visually saw accuracy. Okay. All right. What else we got to do just for answer? All right. So let's check this off. And the last thing is show that your answer is correct with multiple representations. Well, I have multiple representations. I have an entire chart here, right? I have all my things labeled. I have an equation. I have shown my work, and I've given a justification answer. Okay? So this is all set and ready to go. You can now move on to your